Good evening, good evening, good evening, and good evening to you. It's the Monday Night Weather Party. This is WeatherBrains episode number 860 for July the 11th, 2022. This is the pre-show. It is a magical, marvelous time of the program where we do three things. We share boring personal stories, humorous anecdotes, and from time to time we say outrageous things. All right, back on Monday night. We had a Tuesday night special last week with the 4th of July, so we're kind of back on track for a bit. I will have another vacation week in early August, and then my next planned day off will be Christmas. So after that, everything will be back on the typical track as we get into fall. Football season is getting close. Seeing all the preseason football news conferences and everything. So it'll be that time here before you know it. So let's see if we can get everything happening here. First off, we're going to do the embed code so we can be on television. And for those that are new here, we simulcast this on our local in our local market here on the digital weather channels. A lot of people do watch that way, and we are thankful for that. And now we've got that done. We're going to get everybody invited. And we are on a new YouTube channel. You know, we moved a couple of weeks ago. There's always a little pain anytime you move things around, but we just needed to do that because I've been meaning to do it for years, and I just finally got around to it here this year. So YouTube has its WeatherBrains with its own YouTube channel, which is exactly what we need here. And I'll try and move all of the older episodes over. It's going to take a little time. But we'll see if we can make that happen. And I'm getting everybody all invited here. I think we've got I know that Rick is out, and I think Jen is out tonight. But you never know, they might change their mind. They always get the invitation. And hopefully everybody else is in. So let's send out some invites and see if we can stir anybody up here. Hope you've had a good week. A little tropical feature in the backyard here, which is always interesting this time of the year. An old front, decaying front, and sometimes those things can spin up a backyard type system in the northern Gulf. And one way or the other, whether it gets a name or not, it's probably going to produce a good bit of rain for the Gulf Coast. And we tell everybody that's got a beach trip planned, you know, if it was me, I'd go ahead. I mean, different people go to the beach for different reasons. It would not bother me in the least. And I think the sun will be out at times. It's not going to rain the whole time, but it'll be pretty unsettled, and there might be some flooding issues. And some of that tropical moisture will probably start to feed northward with time later this week, but we'll kind of keep an eye on that. Otherwise, the Atlantic Basin is still awfully quiet, and August is getting close. August is going to be here before you know it. Bill has his world map. Is this a new camera angle?
Yeah, I can't make my camera work on my docking station for some reason, so I had to yank it out of the docking station real fast and go to just the MacBook camera.
Okay, that'll work.
Yeah, sorry about last week. Y'all didn't get my email. I didn't mean to be. Never been just AWOL like that.
No, that was odd. You almost always tell us if you're going somewhere. And
oh yeah,
I thought you were totally at the Wesleys or the Hooters or something.
No, I didn't know y'all didn't get the email, so I got this intervention sounding email. Like, is everything okay? All right, I got to get our guests here.
So I saw that Rick is out, and we know that Jen is out, and hopefully everybody else will be around. And for those that are discovering this and looking for the beginning of the show, move the slider over about 5 minutes, and that will kick it off. And for those that are new here, most people listen to this. This is a core audio podcast. We ported this over to video 10 years ago or so it could be put on the television side. And we just have been doing both, but most people listen, about 3 and 4. But tell your pals about our new YouTube channel, and that the old YouTube channel is the James Spann channel, which is the James Spann content. And we can get our custom URL back in I think a week. You have to wait like a month before you get a custom URL. I don't understand. Like, we had to wait a week before we could stream live, and we had to wait a month before you get a custom URL. So anyway, we're going to get there. We will absolutely
make special dispensation for you, Dr. Spann.
Oh, they don't know who I am. They don't want to know who I am.
They don't want to know.
No.
I did not invite Jim Ledoux. Let me say, pull this out of there and do it. Go back and do it.
So we haven't said anything really outrageous on the pre-show in a while. I need to get cranky.
I can't invite Jim. I can only invite Daphne because she's the only one in my email. Why would I not have Jim Ledoux's email address? Let's steal it from Noah.
Well, there you go. And that's a great show title. Steal it from Noah. But we can't use show titles before the show starts. We have to wait till the show starts.
Too bad.
No, we haven't. I've not been on a tirade in a while. I need to go on one of my sleepless rants about something. There's always something. I turned in my newsletter article today.
Your newsletter article?
I'm on
Jen's
duty.
Newsletter?
I'm on duty this
for the
week.
WeatherBrains newsletter. I turned mine in early too. My weather history. Some interesting weather history this week. We need to talk about it.
We can do that. Troy, what was it, 127 there today?
No, we were actually a little cooler today.
Yeah.
110 yesterday and 109 today.
There you go. Still broke a record though.
Yeah. Little thunderstorm, actually. I believe that we would have gotten to 112 today if it hadn't been for a thunderstorm popped up just west of Austin about 1 o'clock. And Camp Mabry, the climate site, was already up to 109. But as soon as that anvil hit the sky, the temperature began to fall over there. And we then got an outflow boundary. And I really believe we'd hit 111 or 112 today at Camp Mabry if it hadn't been for that isolated thunderstorm.
What's your
summer in Austin?
11 or 112?
What's that? The record here, the warmest ever is 112.
I mean, to be, second or third hottest day in history, this is a pretty significant heat wave.
It is. It is.
College Station, I think they were second hottest ever yesterday.
Yep, yesterday. And Huntsville.
You got any rolling blackouts going on?
So far, so good.
Okay.
I mean, little outages, but more. Nothing, I'm told heat related. It's just, I forget, there was one equipment related in East Austin this afternoon, but it was fairly small.
We'll hold it for the show here. I shouldn't be asking this before the show starts because I'll ask you again here in 2 minutes.
No problem.
I see Jim on here. Jim, can you hear us okay?
I can. How about me? Am I good?
Yep.
Is it good?
Hey, Jim.
Wow. Loud and clear.
Fantastic.
Anna, can you hear us okay?
Yes, I can hear y'all.
Okay, cool. And here comes Sam. And I think we can get this show started. Welcome to those watching on television. We're about to start the show here. Sam, can you hear us okay?
Yes, I can. Can you hear me?
Cool. Well, yes, sir. Loud and
All
clear.
right.
Sam.
Well, welcome. Thanks for having us.
Yeah.
All right. Let's see if we get this thing started here. We're going to record track 1, record track 2, and here we go. In 5, 4, 3, 2, 1.
You're listening to WeatherBrains. They're kind of a big deal.
Kind of a big deal.
Yes.
How many weather podcasts have Bill Curtis opening up the show? How cool is that? Hey, this is WeatherBrains. This is episode number 860. This is for the 11th of July, 2022, right here in the middle of summertime. And speaking of summer, let's just go right to Troy. Troy, how bad was it today? You got to be the heat capital of the universe right now.
It was actually cooler today, James. We were, as everyone knows, we're 110 yesterday, and we were only 109 today. So we enjoyed it. And, well, I don't want to push it that far, but it wasn't quite as warm. We had a actually pretty interesting little thunderstorm that developed out west of the city, out around Lake Travis this afternoon. The anvil overspread the sky. And I believe that probably we would have hit 111 or maybe even 112 at Camp Mabry if it hadn't been for that 1 to 2 p.m. thunderstorm. It never even a thunderstorm observed at the ASOS site, but the anvil overspread the sky and it put the city in the shade for a while. So I think we lucked out. As I said earlier in a tweet, I said, I think we sort of lucked out a little bit. We were a little cooler, and I think we would have been warmer than we were yesterday if that had not been the case.
You know, I never use that word cooler down here in the summertime. People get really agitated if you use that. You know, if you go from 98 to 92, it's every day hot down here.
I always say temperature-wise, there are 3 or 4 of the most useless terms in the world. They are hot, warm, mild, cool, and cold. Now, you can prove cooler. You can look at degrees and prove that, or temperature not quite as warm. But temperature terms, I trust my audience to be able to decipher whether they think 109 is cooler than 110. But nevertheless, pretty useless terms, especially in the middle of July in our neck of the woods down here. But even up toward Kim and Jim and people up in Oklahoma, this is not pleasant.
No,
not at all.
Kim, how bad is it?
I was going to say, in my hometown the other day, it was 119 on the heat index in Eufaula on the Oklahoma Mesonet. And so I posted that on Facebook, and all of my friends and family in Eufaula were just really ribbing me about it. So I said it was the most uncomfortable place in Oklahoma, perhaps even the country.
Yeah.
Wow. Kim, how's your heat levels?
Yeah, and Jim might know the precise value of how high we got up to today. I mean, glancing at the Mesonet, it looks like we were at or very, very near 100, maybe 1 or 2 degrees above in Norman. And yeah, it is strikingly unpleasant. I will say that.
Show title.
Kim always makes it so good. I mean, Kim gives it even a kind. I have other names for it, but most of them will get us kicked off even the internet. So
strikingly unpleasant. Yes.
Right.
Now Neil's up there. What is it, like 79 or something? Neil, I mean, you're in the ice
skip by Neil.
Neil. It's nice. It's pretty nice here. Absolutely nothing going on.
I mean, goodness gracious, you got 80 degrees, and what's the dew point up there? It looks like it's fairly low.
It's not too bad. I was in North Carolina the last couple of days, and we've been getting some afternoon thunderstorms, which is nice because my grass was starting to get pretty agitated. But otherwise, it's unremarkable summer weather.
Yeah, we actually had some
55-degree dew point at National, James. So
okay, there you go. 55-degree dew point summer in July. That's a winter. We actually had some 80s around here. The heat's not that bad where we are. But Bill, let's bring in our guest. I'm excited. It's going to be a good show tonight. Go.
Yeah, James, we got a busy show tonight. I guess I better pull up some bios here so I can talk about it. But the show was a last-minute addition. Anna Sims reached out to us. She attended the University of Georgia and was a meteorologist at WTVM in Columbus, Georgia. But since then, she's gone on to do something really cool. In February 22, she started working part-time for Atlas Forensic Meteorology. And she's transitioned to a full-time position there as the lead forensic meteorologist. Anna, welcome to the show. Thank you for reaching out to us.
Hey guys, thank you so much for having me. It's an honor to be on with y'all tonight.
Well, the honor is all ours. You said that you were spoken to by some character named James Spann or somebody like that. I think.
Yeah, one time I heard from that man.
He didn't make
That's all you need to hear from me.
industry.
One and done. It's over.
Yeah. At least you didn't have the experience our friend did out in Oklahoma, Anna. So we're glad you're here tonight. She's brought along somebody special with her. Sam Lane has been interested in the weather for a long time. 1974 seems to be a year a lot of us have in resonance, but his is not the super outbreak. His is the Tulsa tornado on June 8th of 1974. I've heard other people say that.
Yes.
And Sam has done a lot of work in broadcasting Tulsa and Joplin, back to Panama City for a while, and then which we were just down there for the 4th of July. But he's gone on now to help launch Atlas Forensic Meteorology, where he is the senior forensic meteorologist. We welcome Sam Lane to the show tonight.
Thank
Sam,
you all for having me. It's a pleasure. It is a pleasure.
Yeah.
I'm excited to be here and meet everyone.
Well, we're thrilled too. And we got a special thing we want to talk about tonight, and I'm going to let Kim introduce a friend of the show who's been on several times. But of course, many of you saw the photography out of the Dakotas, that derecho, that green hue that was so amazing. And we had to dabble in why we thought that was until Neil and Jim Ledoux and Kim figured it out and told us what was really going on. So Kim, why don't you go ahead and introduce Jim?
Sure. Well, whether or not I actually helped to figure out what was going on is completely debatable, but Jim and Neil are going to help us walk through this whole thing. It's been a really hot topic in the weather world over the past week, and it's a really, really interesting case. I know Jim comes here today. By the way, Jim Ledoux, if you're not familiar, National Weather Service Warning Decision Training Division, and such an expert educator that, Jim, I'm pretty convinced you can teach about absolutely anything, and it's always so well articulated, and you do it on social media, which is even more impressive, and that's part of why I invited you on today. I thought that you had some really great insights, and you'd been turning to some of the research on this, and I know Neil had some thoughts on this too. So without further ado, let's get into it. Jim, would you like to summarize what some of the arguments were that people were making about where did these green skies come from? And I don't know if you'd like to show anything for our audience that's able to view on YouTube. If James, if he can have the screen share permissions, but go and just tell us a little bit about what was being discussed and why you felt like you needed to step in with some thoughts.
Yeah, it's a good question, Kim. And I'll tell you one thing. I'm going to put a disclaimer out there right away, is that, following all of these tweets and everything like that, I've seen the pictures too. And so I had an overnight stay at the hotel to become an expert. I'm not an expert, but I'll tell you one thing. I'll try my best, but I am certainly welcome to engage in any conversation and discussion about this phenomenon, because there are experts that have published about this, and they've written and ran ray tracing programs, using equations, following the light, stepping literally from molecule to molecule, sort of in a statistical sense, to kind of determine what the output would be. And so, in fact, there was somebody, Frank Gallagher. This is a master's PhD student. I forgot which one, but I think he wrote his thesis on green thunderstorms. Literally, this is back in the late 90s at OU. And then we had Craig Bowen that has written a lot about this. Dr. Bowen used to be at Penn State. He's retired, but he wrote a really good book, called, I think, Clouds in a Glass of Beer or something like that. It was very similar to that, looking at all sorts of cool atmospheric physics projects. And so he's published on the color of thunderstorms. And more recently, actually, we've had a couple. 2017 was the last paper I saw on this, and so it's pretty recent. Stan Gedzelman, who comes out of Crest Center City College of New York, and so he's written on colors of cumulus clouds to thunderstorms, and I really liked his article, and so I'm going to share a little bit about that, just to explain. And if I have time, I could explain more than just the green color of thunderstorms. Thunderstorm environments produce all sorts of interesting colors. And a lot of them have been not so well documented, but I'm going to bring them out, and then maybe that might ring a few bells for people's memories to see what it's been like in your experience in seeing thunderstorms, because it'd be really interesting to compare from one part of the country to another and see if we find similarities between all of these. So yeah, I'd be glad to share that.
Awesome. Kim, do you want to proceed right now and go through all this material and then come back around to our other guests, or do you want to go the other way around? Which way do you want to go?
If you guys are game for it, I think that'd be lovely. For those who hadn't seen the skies, by the way, that we're talking about with the South Dakota storm inside and outside of Sioux City, South Dakota, it was like ecto cooler green. It was this extraordinary shade that most people had never seen, including in the chaser community. When the pictures started coming onto social media, immediately people were saying, "Oh, that has to be doctored. There's got to be something going on with this." But when you look at enough of the live cams and other kinds of video and photographic technology, you recognize, no, it was ecto cooler green. That's pretty much what was going on. Wow. And so there were a lot of questions. And it was the 5th of July, so it was the day after the 4th. Lots and lots of gunpowder flying, especially here in the plains. We love America, and we love to celebrate it by blowing a lot of stuff up. So that was absolutely so in the thinking. I wonder, just to set up what Jim is going to give us in a really educational walk through background here. Neil, I'm wondering if you would like to share some of your favorite conspiracy theories that you saw in the thread that I shared or elsewhere, because Neil really enjoyed the science going on.
Yeah, happy to. I'm fascinated by conspiracy theories, and we could talk about all sorts of conspiracy theories, but the ones surrounding this photograph to me were pretty entertaining. And Kim had sent me the link with the photograph, and I thought, wow, this is a mix of absorption and refraction, and I've seen it before. It makes sense. It's not that much different than the physics behind the green flash that some people see with the sunset in the ocean. And but I started reading all these tweets from people that were like trying to explain it, and they're like, "Oh, this is ionization," and like all this stuff. And then I was like, "Where this is like so overthought. Like, where do these people come up with this stuff?" But I still had to think it through to convince myself that they were wrong. And the 4th of July thing did kind of cross my mind, because a lot of times you'll see pretty red sunsets because of a lot of the scattering up in the stratosphere after volcanic eruptions and things like that. But then I thought, no, that can't be right, because then people would be seeing green all over the place. And it's not like there was green photos all over the US on the 5th. And the interesting thing about the ionization stuff, and I just thought, if that was really the case, and there are things like ozone and things like that get produced with when lightning strikes, but you would see thunderstorms glowing in the dark all night long every night if that was actually true. And so a lot of these things are pretty easy to disprove with just straight up logic and no science, but it was still entertaining to see someone throw something out there and then just everyone else pile on like, "Oh yeah, that makes total sense." And I'm just like, the internet is just anti-knowledge. This is crazy. So then I wrote Kim back and I sort of explained it. And then I put in some references, but I didn't realize it's like everything else I think of. I come up with a cool idea, and then I go on Google Scholar, and there's already like 2,000 papers published on it. And then she's like, "Oh, I talked to Jim. He said the exact same thing. Here's his tweets on it." And I was like, so at least there's 2 people who understand this on the internet, but those odds aren't very reassuring for humanity.
I've got to say, I will admit, and I think this is true for a lot of meteorologists. It's possible that like our radiation classes where we would learn some of this stuff, it's not what comes naturally to a lot of meteorologists. I think a lot of people get into it for more the fluid dynamics. And I mean, atmospheric radiation and all of those principles are just a really different can of worms. I think that it's very easy to go your whole career, and our forensic meteorologists can speak to this too, to go your whole career, and that's one of the relatively less used parts of your brain. You don't use it, you lose it. And so for me, it was fascinating. The people you're talking about putting these ideas forward weren't just random chase yahoos. A lot of them were people with master's degrees, PhDs, piling in, and operational meteorologists from our national centers. And it wasn't like a bad crowd operating in bad faith. It's a bunch of people who are trying to reason with, well, gosh, we've never seen this before, so it has to be some unique something.
Well, that's the interesting thing about science. I mean, people throw crazy ideas out there for hypotheses, and if they're easily falsified, then so be it. So it was working the way it should, I think, from a scientific perspective. But I thought the same thing when I first saw the photo. I thought this is oversaturated, and then I started looking around and thought, wow, there's a whole bunch of video and everything else. This is actually the real color. But I never learned that in meteorology. I mean, my undergraduate degree's in physics, but I mostly learned it just from photography and things like that. And so when I was doing a lot of like post-processing of photographs and imagery, it was always like RGB versus Cmyk and stuff like that. And I called it before it actually happened. I said, this is going to divulge into some discussion about color saturation and RGB. And then it happened. People were debating about, green's not a primary color. Well, I mean, in pigments, maybe. And then there's a whole discussion on the map listserv about this stuff. And it was, and they were both actually right, but it was pretty entertaining to see people. I mean, these are PhD level scientists arguing over, what the primary colors are.
Yeah, it was, and then talking about eating paint. It was a great thread on map. But without further ado, then Jim, educate us. Tell us a little bit about what you learned, especially with respect to the limiting into this really narrow spectrum of green. I think we've all seen sort of green, in storms. You hear this like hail, if there's hail around, you might see green, like these rules of thumb. Tell us, what's the reality here, and what was the likely set of conditions that went on to produce ectocooler green?
Yeah, I mean, the ectocooler, I love that name. And in fact, there's actually a web page where you can submit that name to the color wheel. Maybe I need to pull that up again. I think it's colornames.org, if I may. There's only 2.9 million names entered so far, so 17% of the color wheel's done. But if you will, the one bottom line thing is that our eyes register or perceive a specific color, and it doesn't necessarily imply that color or the amount of radiation pouring into that specific color space, is huge compared to the rest of the visible spectrum. It just might be a little bit more than the rest. And suddenly our brain clicks in and then registers that color, as being green as opposed to maybe blue or even yellow. But I think what was so amazing about that day in South Dakota was that I think that color was extremely pure. In other words, there was a lot of radiation pouring out from the rain shafts and hail shafts as that color green. And in fact, if anything, I might say there was a little bit of yellow with that too. So I think because of that, the purity was a little bit better. It wasn't smudged. The color wasn't smudged across several, a broad band, so to speak, which most thunderstorms are. And I hate to say this, but the photographs that I have, I can't match the purity that we saw there in that color, but I do have something pretty close to that purity in another color, which is interesting. And why they're different kind of just reflects the broad complexity of the thunderstorm environment, where you just need a little more cloud density or liquid water density, the raindrops a little bit higher, a little more ice content. I mean, there's just a million variables in there that affects the outcome of the lighting. And it's not just that, but it's also not just the direct light or scattered light from the direct light like the sun, but also scattered light from everywhere else around your sphere, behind you and in front of you. So yeah, and anytime, we could kind of go through a short tour of some of this here. And I'll tell you one thing, you might have to, use the hook to pull me off the stage because I could go on forever. And I know that we have other guests here. So please let me know if I run out of time.
Yeah, you know what, Bill? Do you feel like we're good for a couple minutes of?
No,
we got all night. We've got all night.
We've been known to go to 11
All right. Well, go ahead, Jim, and we'll just let you know, when we want to wrap in some of our forensic Met colleagues and learn a little bit more about their business.
All right. You should see screen come out. Do you see that? It's got
yes, we do.
Number one article. This is my best article because it's not just the most recent, but it's actually in full color, which a lot of the older colors are black and white. But it's Dan Gedzelman. You can actually pull him up, and he's got more than just one article in applied optics. And to me, it really represents kind of the merger between meteorology and photography and human vision. It's almost like there's a medical component, a photographic component, and then what can I say? Paint tint producers. If you think about it, there's color swatches of rugs and paints and things like that. The one key thing, and this comes out more and more, and I've seen this before, and I saw it on the map list server as well, is that we wind up with this conversation about it's the smoke, and the smoke produces a yellow tint. And hey, if you merge that with cyan, you get green or something like that. And there's one big concern about that line of reasoning, and that is that we're assuming we're in what's called a CMYK color space. And that is used for print, assuming that you have a piece of paper as a white background and you're subtracting colors from that white, because the white reflection represents all of the colors. Okay, it's just like the color snow is the same thing. And snow and paper and other white things share that. It's all reflection, all colors represented, and you want to take out various components. And so the print community, and this is graphics artists and photographers, have to make sure that they have the right color matching scheme in their Photoshop and make sure everything is calibrated to CMYK so that what they see on their screen is what comes out in the printer. Okay, well, that's not the sky. The sky is a singular light source where color is coming from the sun and being scattered, and it's adding color to what would otherwise be a black sky space. And that's the difference. And because of that, you have to go into the RGB color space. And that's the same color space as your computer screen, or slide projector for that matter. Anyway, it's actually more the computer screen, so to speak. And so that's an additive color scheme. And so we have to think along those lines. Now, here's another component. I bring this up because color is also perception, and our brain does some wonderful things to interpret the color spectrum and to create a color. Your brain is coming up with a decision as to what color a new feature is compared to the others. So this is a classic example of where sometimes you can get fooled, and some people get fooled by this, and it's not a particular flaw. It's just kind of how we've been trained to survive in this environment. And so we often, in our brains, automatically white balance things out. If you put on a pair of sunglasses with a color, pretty soon you don't notice that color. That's the analogy here. And so you look at this and you see these balls and you go, wow, okay, how many orange balls are there here?
4.
4, okay.
I see 4 of all the colors.
You see 4 of all the colors. That's right.
Yeah, 4 blue, 4 red, and 4 green or yellowish color.
Yeah.
Until I start really looking between the lines.
Don't look, and then start revealing the truth.
And then they're all orange.
They're all orange. Let's go ahead and wipe out the colors of the bars, and you can see exactly what goes on.
Oh, wow.
Ooh,
Oh my gosh.
Go back and forth between these two. And I wish, I know that the podcast people, you're not going to see this, but it's a bunch of balls on here, and we have red, green, and blue bars crossing, but only a certain color crosses in front of the balls of one of those colored bars. And that sets the color for the entire ball that's behind it. And that right there says to you that, oh, you got to be careful. And so, yeah, sometimes it's worthy of taking a deep dive into it, making sure that, that it's set right. Now, here's another thing too. The Photoshop artists out there like to go ahead and put this color scheme out, and so they'll cast their entire photo in a green tint or something like that. And that's where also you have to be careful about, because I think some of these photos were, it's conceivable they were touched up because they wanted to bring it out. And I think there was one that, I'm a little bit suspicious, but right now I'm not going to single anybody out, any photographer. I'm just going to say, yeah, viewer beware. So anyway, yeah, there's that. So you can see, these colors are amazing. The purity of this color here with this storm.
Wow.
And not only that, but I keep thinking, it's like, holy cow, the entire cloud base, the Arcus cloud, that big shelf cloud is colored green too. So I'm going to be careful about that, because some of this, for instance, over here, this is all green. It looks like there's a monotone background color, like the whole tint was applied, but I don't know. That's the thing. So it could be one of two things. And let's just assume it wasn't Photoshopped. All right, let's give the benefit of the doubts of the photographer. It could be that this is just so brilliant. The light is actually coming through and making it through without being absorbed or scattered. And so that's pretty amazing. And some of that may be due to the fact that the sun angle is really high. And I'll call it, it's way up high. That's, or the zenith angle is really low. That's the angle from straight overhead. And so that's just brilliant. And of course, I like this tweet comparing the two derechos that occurred up there in South Dakota. This is this one here is a little bit of a prelude to something I was going to show too, something else. But apparently the news media up in Sioux Falls is calling one the brown derecho and the other one the green derecho. So I think
almost looks like a haboob.
It is. Yep, it's a haboob. Absolutely. It was dry across Nebraska, and so the derecho started there and picked up a lot of dirt. And and I don't know if you've seen some of the videos where that dirt crossed over the videographer and the sky went black.
Wow.
Literally black as ink, midnight. And I've never seen that, except out in Arizona, some other pictures up there, but in the plains, I haven't seen that. It's just probably a sign of drought characteristics. So yeah, this derecho was severe. These peak wind gusts were really high, 80, 99 miles an hour up northwest of Sioux Falls, 75 to 80. If they didn't have the May derecho, this would have been a big event up there, but May beat this out. So, just as a background here, we're looking at all of this, the visible light spectrum squeezed into the electromagnetic magnetic spectrum here in a very thin area. So, if you think about the whole spectrum, I can only imagine the impacts across this whole thing, but we'll just focus on this. So I'm going to compare, and this specific spectrum here, and I'm going to rattle around wavelength names, but this is wavelengths in nanometers. You can say micrometers. You might see 4 to 7 micrometers, or 400 to 700 nanometers, so forth. So I got this color spectrum somewhere else as well. Whatever the case is, just remember red is with 7 micrometers, blue 4, and then kind of in the middle you see the yellow right there, like 5.5, and so forth. That's key. So this is cool. All right, so this is again from Stan Gedzelman, and he describes 3 different unique environments where thunderstorms get colored, and this is pretty frequent. And we're not just talking about ambient colored light reflecting off the clouds and coming back at you. I mean, there's that too. This is stuff that is a result of scattering and absorption and all that, So we have the sunlit side. This is option 1, where it's color filled, and you can see the gradation of colors from deepest red to brighter red, higher up. Then you got number 2, which is that aquamarine, that greenish cast underneath the storm. And then you got this east side, and I guess there's descriptions of this, they call it sickly yellow. It's like the sky was yellow before a tornado or something like that. Okay, so then there's that as well. But I think we all know about the sunset, and you got this red sun as it sets because the blue is being scattered away as it traverses a long path through the atmosphere. And so with this low sun angle and with that long transit, you see how the graduation of the colors goes from basically red here, where all the blue has been scattered out, and then the light that's coming up from higher angles comes in mostly blue. And we see that reflected on the clouds. This is another example later on, as the sun has set, and you still see that same thing, the yellowish to the green, blue, and maybe even purple. This is electric blue sometimes in the post-sunset sky that just, my wife that's her favorite color, is that electric blue. And so then we have that one. So anyway, but you can see it reflected during the daytime too, and this is what happens. So you get if you're up in a plane, or if you're looking at a distant storm relative to a close cloud, you can see that the distant storms have a reddish cast, and everything closer is pure white, because the blue hasn't been scattered away. But this stuff, the blues got scattered away a little bit, and so you get this reddish cast left behind. And so that's similar to an evening sky in some ways. That's what we call Rayleigh scattering. It's the scattering of light due to the molecules in the atmosphere, and that's what we got. It does the opposite. If you have a dark object a long ways away, all right,
the Death Star,
the Rayleigh scattering the blue, all right, it actually fills in the gaps and illuminates, it casts a blue shade to everything. So I was thinking about a distant picture of the Smoky Mountains would be a good example, that blue haze. But the Death Star works out pretty well too, and Hollywood got this right in Rogue One. And I thought, oh, that is the way it ought to be. Any sci-fi movie that doesn't take into account Rayleigh scattering is flawed, and they should be called out. So let's go on here. This is another example. So the way Gedzelman, came back and said, yeah, this is, an evening light. You should see the back end of storms much redder down below, lighter aloft. And you see this classically in this one right here. And so that's that graduation color, mostly Rayleigh scattering. All right. Well, you know what? He found out that Rayleigh scattering operates inside of a cloud too. But then there's an awful lot more that's going on, because it's not just Rayleigh scattering, but now you have cloud droplets, ice particles, liquid drops, all sorts of things, different sizes and everything, and different densities. There's some, and so there's physical scattering, there's absorption going on, and water likes to absorb red. That's why you see the bluish cast, for any picture that's underwater. If you're underwater, you see the blue, and the blue gets deeper and deeper as more the longer wavelengths go. So that, results right there in when you have a sun coming in. By the way, this is a tornado in Norman. This is Northwest Norman, Oklahoma, back when in 2015. And a lot of people in Northwest Norman remember, well, everybody here in Norman remembers this storm. But you can see this bluish cast here. Hopefully you see that, and because you never know how many times this color gets retranslated across internet. But that is coming through the vault in the clear slot in the rear flank downdraft, where there's a lot of precipitation. And so, and of course, what you're doing is you're looking up into the weak echo region of the storm, the bounded weak echo region, where you have kind of a hole, but then all around it is tons of rain and hail and things like that that are absorbing the reddish, the longer wavelength colors. But there's also a lot of Rayleigh scattering going on. It just happens to be that's not quite as long, unless it really gets thick in there, and then you got light waves that are just bouncing off precipitation and cloud droplets all over the place, and their effective lengths, as something gets scattered around like this gets so long, it literally, the storm makes it as if a light beam is going through a long ways, much longer than what the direct A to B route would be. So if you want something pure, okay, I don't have that, but this storm, which everybody I think knows, literally is a day of infamy in Oklahoma, which is the El Reno tornado in 2013. And the one thing, if you go back and take a look at this, and one of them is, you can find a website, you can Google search it, and it's called the El Reno Project, which Anton Simon and co-authors have created. You see all these videos, and it's just incredible teal color and pure at that. And some of them are much better than my picture. This one here, we're blasting south and trying to get out of its way, and looking west and noting, oh, nice color. All right, let's get the heck out of here. And so that one there, I think, is due, mainly because, this is an incredibly tall storm, had a huge volume of water, high density through a deep depth, water and ice. And so where the light was allowed to pass through was in this area of larger droplets, sans cloud material. And once that happens, we can get through and see that deep teal color right there. It looks a little bit more, I don't know. Maybe I'm putting words into your mouth in terms of what colors to name, but so you can disagree. You're all welcome to disagree. If you see a different color than what I do, it's because of the other perception. What your frame of mind is seeing in your particular context. Or maybe your screen color balance is off. I don't know, but in this case here, this is a mix of blue and green, and this is rather dark. The blue hasn't been scattered out yet, but certainly the red and the yellows have. Okay, so that's a lot different. All right, so another one too. This was a particularly large and intense storm in southwest Oklahoma that nobody remembers, but it was all the power and strength of the El Reno tornado. And I don't know if you see it, maybe in the last bit, you might see some teal or something like that, wrapping around here. Mm-hmm. I slow it down. You see a lot of this, it's a little bit more green, maybe a little bit of yellow attached to it. It's higher up in the Ford Vault region. And that, again, is that cast as the red is coming out, but there's still a little bit of other color. But again, it's not strong. So there's light in all color ranges coming in. It just happens to be the green and maybe a little bit of yellow is just slightly dominant. In the last bit, you see that green color right there. So anyway, let's see if I can get past this guy and move forth. Another good example, this is an evening storm. This is the day before the El Reno tornado. And we see this a lot. We see this very subtle band of green right here, tucked up against the top of the shelf of the, oh boy, I could say this is the lower part of the updraft. It's the updraft foot. And you get these collars of green that can occur right there, where again, in that notch of cloud, it's not up the, up the rear flank downdraft, but it is a notch where there's just a little bit shorter path lengths to allow some of that greenish light to come in. That's been filtered out here in the deeper parts of the cloud. So there's all sorts of other colors in here, and I can describe it later on. Don't know if I can talk about colors of lightning, but we can talk about that too. There's another one too. This is that same color up here, Does everybody see that? And you can see, again, it's this brightish, almost yellowish green, rather subtle, but kind of tossed around the entire part of the forward flank precipitation that's coming out from above the storm. So that's a good example. Clearly not that pure, that neon green that we saw. It's not the most pure color, but elements of the same colors are there. A high precipitation supercell is the same thing. But the cloud, you can see here, the cloud is too thick. It's mostly blocking all of the sunlight, and anything that's coming, the only reason you see it's not pitch black is because of reflection and maybe the 1 or 2% of the light that's able to get through. But where the precipitation is, more of the green and blue can come through and get there. Now, this is not the teal color that the El Reno tornadoes or some others that I've seen, like, that Norman storm. But, so that's an interesting thing. Why sometimes the blue gets filtered out as well, but sometimes it has to do with the path lengths, that Rayleigh scattering filtering the blue out. More typical squall line is like this, and you get that. I think this might be a more universal appearance to storms that you might see in other places where the green is coming out through the precipitation shaft. Sometimes it's not just green. Sometimes it can be a cyan kind of color as well, that blasts out. So there's rather interesting variations that sometimes I just, I can't totally explain. I mean, it has to do with the subtleties and the natures that I talked about earlier. So, this is, I got plots here and I have to say, but this might be a typical graph where you can see what the sunlight spectrum is in this curve here, where the highest intensity of light is coming in from the top of the troposphere onto a storm. And then as the light passes through, this is Stan Getzelman's model that's producing this. And you can see what happens as the light gets filtered and absorbed. There goes the reds and especially true for larger drop sizes. You can see that it's coming through, and what you get left is this area in the blue-green spectrum that's left behind. And sometimes a little bit of that yellow that might pass through, but you can see it's broad. So you get that broad kind of color right there. All right, so here's another one. This is something I want to point out, is that there's been a lot of talk about, and I still see this all the time. So Neil, I'm going to add to your conspiracy theories. People say it has to be large hail, right? It has to be large hail to produce this. And I see that. And also it's like, well, if you see green, it must be severe. Okay, so there's some truth, and then there's some other issues that go along with that. And it all gets grouped into one basic, theme, and the nuances get thrown out, and then boom, it's suddenly this. And one of them is that if you see green in the precip core, it must be severe. And I hate to say this, but there's some truth to that, because all the storm pictures that I showed you up to this point were severe of one form or another. But so was this one. And I don't think you see, I mean, you can correct me if your eyes might be better than mine, and you might see some color in there. But I certainly don't see the intensity that I see with the other pictures. And because of that, I can say this is a null event that's severe. And that's the problem, because if you're going to hang your hat on taking shelter because something appears green, then you're going to be unpleasantly surprised by this one or this one, or this one for that matter. And while this one looks kind of innocuous, it's like, hey, I can see sky behind this over on this side of the storm. I can guarantee you there's baseball size hail falling out of this apparently transparent side of the storm here. And I think it also says something about why we're not seeing any colors. I think one of them is that the sun angle is so low that it might be hard to get it, but there is sun illuminating the top part of the storm. And why you don't see any of that teal or green is probably because of this fact that so much light is getting through. The precip density is so low, okay, that it's not selectively absorbing. and there's not much scattering of light redirecting it to increase the path lengths to filter out the red. And of course, there's not much blue. Well, not at the low sun angles down here. There's not much blue that's going to get through. We just wind up with a big dark blob because this is very dense cloud, and it's basically absorbing just about all the light. So that's a different one. And another one here is after the sun sets. All right. Do you see any blue in this picture?
Everywhere.
Everywhere.
Yeah.
Everything is blue.
Yeah. Here's the vault. Here's the updraft edge right here on the north side. You should be seeing the blue and teal here, but maybe not over here or anything like that. And so I think that's the difference. I see it all over the place, from the left to the right. And that's because all the light is blue. Now, sometimes, you can get path length that's, totally blue it all gets canceled out. Of course, at night, you can't see anything. So that leaves this last part, this color. Let me ask you if you've seen this color here, right here along the apron of this storm, which happens to be the El Reno storm just before it produced the tornado. All right, now you see it scattered all over the place. So imagine this. Now you have literally the sunset effect in reverse, because you have this huge anvil. It's coming overhead and it's blocking the entire sky, except everything to the east. And the path length, this anvil goes like 40, 50, 60 kilometers to the east. You wind up, the only light coming in from that side impacting the cloud is forced to go through a long distance of atmosphere. And so it's literally the same Rayleigh scattering, filtering out the blue and leaving the yellow. And if the sun is lower, so that light to the east is already yellow, it's going to get orange and maybe even red. Although I haven't gotten a picture of red, but there it is. And I've seen this too. In fact, let's go back. You probably haven't seen it, but take a look at this color. Okay, up here. All right, it's the same thing. And then it's reflecting off this inflow feeder band that's coming in. And you see that same color, maybe a little bit here, that same color. Yeah, well, that didn't work out too well. But I have others as well. I think that's about it. So we have like 3 or 4 other pictures here where we're sharing that same front lit color due to that Rayleigh scattering. So sorry, I'm going to make you dizzy here by bouncing. Oh, this is a classic. Now, this one we had the cyan colored core and that front lighting, that warm front lighting. And then what the heck color is that? I mean, that's slightly greenish cast. It's a slightly less dense atmosphere as opposed, the precip here is slightly less dense than this stuff. So a lot of smaller drops and things like that in here that could be filtering out everything, more stuff than just the blue. But why isn't it teal? But it's less green, so we're getting a little bit more of the blue in there. So that's really dense. Okay, so that's it. I don't know. You can cut me off here, or else I'm going to show you a couple mysteries here. All right.
we're all for mysteries.
Yeah, this is a tough one. It's not even a thunderstorm, first of all. Okay, so this is cool. This is a dust cloud.
Right.
It's a band of dirt coming right to left. Here we are at the Weather Center, just on the north side. And Kim, you probably recognize this. Brilliant red sky. And then we also have, I think we have a lot of blue as well. I didn't put it in here, but I should have. Yeah, no, I didn't. Okay, so there's a lot of blue and there's a lot of red. What color is this dust?
Looks purple.
Purple.
Mm-hmm.
That's right. Okay, so yes, I did enhance this a little bit, but I didn't add it. I didn't add the purple. What I did was, I took basically, it's a high dynamic range picture, but you'll have to count my word on this. And of course, that's my reputation on there. So the individual pictures in here, I look at the RGB values on my Lightroom software, and blue and red come out to dominate, okay, at the expense of green. So we don't have much green, but as you can see, the sky is full of red and blue. So if there was a combination of the two, it managed to scatter its way through this dust cloud. Okay, you get something that has this slightly purplish, so it's purple dust. But it's not ubiquitous. I got another dust cloud here. This is in April 29. This is up in Kansas. And this storm is about to produce a bunch of QLCS-like tornadoes. But just before that, behind the cold front is this conveyor belt of dust. And I think this one's a lot more just gray. And I think because it's typically just one color back here. It certainly doesn't have the background brilliance that this one has. So anyway, that's in a nutshell, some of the things. And I got all these links here, and I can certainly share these with you later on. But if you ever wanted to see, I think some really useful links. Oh, this one here is a go-to one just for sun angle. If I want to pick a sun angle for any time and place and so forth, this one really works well. Let me see. But I also have this one. If you ever wanted to, try to match the colors, you can always see how they convert from the screen kind of interface to that cyan, magenta, yellow combo down here. So I can turn that and you can see, oh gosh, I got this one here. It's got some cyan and yellow in it. In other words, based on a color scheme like this, if I did more of a teal kind of thing, I can see that right there. But pure green and yellow, like what that color is, you can see how it comes out cyan and yellow. There's very little magenta, no magenta in this case. And I don't know if that's the color I got. Maybe it was more up here that the South Dakota one is. So I probably came up everywhere short of actually explaining why South Dakota was different than the others. And for that, I'll apologize. But I think the key thing is that it's something that we can do something about. Nobody has ever taken a look at the dual pole radar data and try to backtrack out, all right, some real observations and try to apply that to a model. So far, all the models just assume a certain drop size and a certain path length from top to bottom in the storm. And I think we can do a little bit better with that with the dual pole. Most of the research has been before dual pole radar data has been made available. And in addition to that, also with the quality geostationary satellite data, I think we can do a lot better. We have cloud optical thickness products from the satellite, and we have dual pole data from the radar. So anyway, I'll leave it there. I can turn the screen or give it back to you, I think, in some way.
So I've got a couple of thoughts and points, and then I'll hand it back over to the other guest. So I was in the process of printing out some business cards a week or two ago, and I won't name the company that I used, but they had a hilarious thing on their website, and it was basically, I'm paraphrasing this, it was like if you designed your card in RGB and sent it to us and not a vector file, you're an idiot. Make sure you convert everything to CMYK first and send it to us as a PDF. Otherwise, your colors won't match.
Yeah. Yep. Otherwise, you'll be left at the whim of whatever software system the provider operates in, and especially that's the case. I try to do my best before I send a picture to Walgreens to get enlarged.
The other thing I was thinking about, and this just occurred to me recently. So back in a previous life, I actually used to work in aircraft avionics and ice detectors. And there's the state-of-the-art ice detector system for most commercial aviation actually has two different wavelength laser emitting diodes. And the reason why there are two different wavelengths is they are trying to differentiate between clear and rime icing. And one wavelength, which I think is in the red, can't penetrate either. And the other in the green can penetrate clear, but not the rime. And the rime the clear is the real problem, because prior to these ice detectors, the state of the art was look out the window and see if it's accumulating on the windshield. And of course, clear ice is kind of hard to see if it's accumulating. And so anyway, that just totally random. I guess maybe to the listeners out there, I think we should do a show on conspiracy theories, like just devote an entire show to conspiracy theories. So send us your best conspiracy. So actually, let me take that. Let me take that back. Send us your best.
Right down the tubes.
Send us your best theories. Send us your best theories, and we'll tell you whether they're conspiracies or not. How about that?
There you go. Just kind of our own Snopes for the weather community. Yeah, all we have to do is turn the comments on our blog, Dr. Neil.
Yeah, we certainly got more than our fair share. That's one thing I was talking about this to a friend of mine today. It's like, if there's a required course in high school, it is how to filter through this stuff on the internet.
Mm-hmm. That'd be a good idea.
Critical thinker. And I mean, I can't overstate the importance of that.
I have a list probably 300 deep of conspiracy theories that when I was at NOAA, I got emailed all the time with theories, great ideas. Why don't you try this? It was pretty amazing. I kept them all.
And you were the recipient of that. That's wow.
So Neil, were any of the conspiracy theories related to the fact that there might have been a high C factory somewhere near the storm that had been destroyed? Because I'd never heard of ecto cooler. I guess Kim came along at a later. I had to Google that term too. But when I saw the picture of the high C, I was like, okay, that's where that color came from. Yep, I get it totally after seeing that. Well, this has been fascinating, Jim. Anything else for Jim before we let this subject rest for a little while?
I had a couple of comments or thoughts. A lot of these pictures seemingly are taken at around the same time of day. So you have to take into account the sun angle, also maybe the time of year, which the zenith changes throughout the year. So all those factors, as you mentioned earlier, there's so many variables that contributes to what we perceive as color. And I don't think a lot of people kind of step back and think about all those variables as to why they are or why something looks the way it looks.
And it's really hard to predict ahead of time that the early modeling, this I'm talking about Bohrens and Franks and early, before Gallagher, actually, before his master's thesis, only picked the low sun angles or a high zenith angle. And because that's when all the observations were. So along comes the South Dakota event. Now, fortunately, Gedzelman actually picked and actually ran his model through all sun angles, literally. And in some ways, actually comes up, when you have a higher sun angle, a little more yellow does come through. And now I don't know why the blue suddenly disappeared in that one, but a little bit more the other colors does make it a little bit more intensity, I guess, or maybe just the right combination with a slightly less precip density and depth. You can get a little bit more of that in. So maybe that's the reason. They used to think that the green wouldn't happen at high sun angles, but obviously that's not the case. I mean, we're seeing this. The only time of day where I can see it not happening is after sunset.
Interesting.
There's one more thing too, and that is it's actually the distance of the observer to the storm, because the light is ray tracing through. It's still undergoing scattering and selective absorption. So in some cases, the green might actually be stronger a little bit farther away than closer. Maybe not South Dakota's case, but in other cases.
I think I don't know if there was a paper written on it, but I think I've heard about a research paper talking about how rainbows in Hawaii are supposed to be the most beautiful rainbows in the world in comparison to other places. And I don't know if that's true, but but that would be an interesting, maybe that's a conspiracy theory that we can talk about for all of our Hawaiian listeners or viewers. Maybe they can shed some light on that.
I do know for atmospheric, frozen atmospheric optics, right? You get a huge array of all sorts, and I'm not going to even name them, beyond just the halo. But the best ones are in the Arctic or Antarctic. And I think that has to do with the monotony of the crystal shapes. They're literally almost all identical. And boy, that's hard to do around here.
Yeah.
That actually reminds me of, I saw some Photoshop double rainbows, and here's a secret trick to tell if the double rainbow's Photoshopped. If the color order is the same in both, it's a sham.
Yep.
I think it's interesting too. Someone mentioned earlier about atmospheric optics was just kind of one of those gloss over chapters in meteorology where, it's kind of like, well, we're going to talk a little bit about it, but we're not going to really go into depth about it. But it's a very interesting topic, and I don't think there's a lot of research really actually done on it. So someone mentioned in the group that it would make a great master's thesis or something to kind of go in more depths about this. And also I wonder what the relationship between maybe space weather and atmospheric conditions, because, there for the longest time, when pilots were reporting these blue jets and these sprites, they were kind of discounted as, where they're crazy. And as a matter of fact, a lot of pilots refused to even admit that they saw things like that because they didn't want to lose their pilot's license because they thought they would, be thought of as crazy. Well, now come to find out, we know it's an actual atmospheric phenomenon. So who knows? Maybe there's something to that.
Yeah. And what else are they hiding, by the way?
Right.
Thanks,
right.
Chemtrails.
There you
well,
go.
Neil might know about that. Right.
Well, this has been a fascinating discussion, and Jim, we appreciate you leading us through it, and just the back and forth on the panelists was just priceless over the holiday weekend. So we really appreciate that. So Jim, stick around. We're going to turn you into a panelist now. We're going to talk to Sam and Anna for a little bit. And,
absolutely.
Talk about what they're doing. So Anna, you wrote us a quick email and said you'd heard James speak at Georgia. Talk about how that impacted your path as you were going along, and then how you made the move to go from broadcast into the field that you're in now.
Yeah, so when I was at University of Georgia, I think it was my second semester there, first or second semester, James came and spoke to our class of atmospheric science students. And when he did, I called my mom right after. I was like, okay, I know I said broadcast was the last job I wanted to do, but I want to be a broadcaster. I said, I want to be in a rural market where I can cater to people who don't get a lot of attention. So my family has lived in Harris County, Georgia a long time, and I decided I wanted to come back here and be a broadcast meteorologist. After 2 years, I decided to hang that up. I'm now working for Atlas Forensic Meteorology. I began working for them part-time while I was with WTVM in Columbus, but ultimately decided that I wanted to do that full-time and pretty much leave the broadcast world. I'm probably going to freelance a little bit still for WTVM here and there, but other than that, I've kind of hung that chapter of my life up now.
Was there any part of broadcast that didn't turn out to appeal to you as much as you thought it might have, Anna?
Probably just being in the public eye so much. I've always been like a really private person, and I did watch the WeatherBrains episode with Taylor and the other female meteorologist speaking about the harassment of women in the workplace. And it wasn't any coworkers or anything like that. But definitely that was a huge part of it. So.
Yeah, that's just a shame. And that was a very sobering show. If you haven't watched it, go back and watch. It's not easy to watch for sure. And you begin to wonder how this stuff still has a place in society today. But as you see, there are monsters out there that, unfortunately are, and people who just don't have any couth. Right. That whole spectrum, can ruin it for a lot of people. And I'm sorry to hear that you went through that now. But we're glad you're here. I've always, I don't know that we've ever had a guest that was a forensic meteorologist. Of course, we've had, several forensic meteorologists amongst our teams. Brian Peters, Tim Coleman, Dr. John Scala were really great forensic meteorologists, and we never really talked to them about their craft. We just knew they were always busy, so there must be a lot of work out there in this. So talk about that, Sam. What is a forensic meteorologist, and what do y'all do?
Well, it's a new, I consider it kind of a new and exciting branch of meteorology. I think it's a branch or an area of meteorology that a lot of people don't even know about or knows that it exists. I think for a lot of times or a lot of years, broadcast meteorologists were called upon by various attorneys from, and I'm sure James maybe have gotten some phone calls like that. Hey, can you look up some weather data that occurred at a particular place and so forth? But what we do, well, I'll just kind of tell about how I got into it, and I think that might explain a little bit. I was actually looking on Indeed.com once, and there was a forensic engineer who was looking for someone to just pull weather data. And I thought, well, I can do that. I mean, I know how to do that. So I reached out to him, and after meeting with him over dinner, he realized, and I think I did too at the same time, that there was a need for him to start a meteorology company, a forensic meteorology company. And so that's kind of how we got started. And I'm going to go a little bit, and the forensic engineer reached out to me, and the reason why he did, and this was shocking to me when I found this out, he was discovering that a lot of forensic engineers was using weather data and then testifying about that data when they really didn't understand what they were doing or how that data is used and what the limitations of that data is. For example, and someone from the Weather Service could probably speak to this a little bit better, but whenever a storm event occurs, the National Weather Service wants to get storm reports coming in so that they can verify the warning. Once that warning is verified, a lot of times the meteorologist will then move on to the next thing or the next product that they have to put out. That doesn't necessarily mean that they got all of the reports that came in from that storm. But what was happening was that data was then being sent to the National Climatic Data Center. And then these engineers were getting a hold of that data, and not just engineers, but insurance companies, public adjusters, private adjusters. And let's say, for example, a storm went through a rural area in Kansas. Well, if there wasn't a storm report reported to the NCDC about the hail that occurred in, let's say, Yates Center, Kansas, well, according to the engineers and the insurance companies, it didn't exist. It didn't happen. And I'm like, so he's telling me this, and I'm like, you're kidding me. And he goes, no, this happens all the time. This is a common occurrence in these various disciplines where they're using data that is compiled by meteorologists, but it's being used in the wrong or perhaps incorrect or inadequate way. And so as an engineer, he had enough appreciation for the science of meteorology to understand that I'm delving into an area that I don't fully understand and comprehend. And I recognize my limitations, and I need some assistance and some professional help. And so that's why him and I got together and we started Atlas Forensic Meteorology. So now what happens is Atlas Forensic Meteorology, our biggest customer is this forensic engineering firm. Whenever they're called in on a case for either roof damage from hail, wind, lightning, hurricanes, we've done hurricanes as well. If it has something to do with weather, he then hires Atlas Forensic Meteorology, and then we go in and we actually do the analysis. We look at the radar data. We use GR2 Analyst 3. We use all of the weather data sources that are out there to try to compile a more accurate picture of what actually happened. And so that's kind of what we do. And one of the things that we'd like to do more of, and we're actually encouraging people to check out our website, is hail is not sexy, okay? So as a result, all of the research money goes towards hurricanes, tornadoes, things like that. But there's not a lot of research that has been done on hail. even though hail is one of the biggest damage producing weather phenomena that we deal with. And so there's been some research on hail. And of course, they changed the hail size from 3/4 of an inch to an inch in diameter before it's considered severe. And there's a lot of dispute about that because the kinetic energy of a hailstone changes based on the velocity, whether it being dropping straight down or whether it's being hurled at 90 miles an hour. For example, we were talking about the South Dakota storms the other day that occurred. We were looking at the various colors. One of the videos was a car that was parked underneath a gasoline station awning. And to me, from the video, it looked like the hail was smaller than an inch in diameter, but yet it was being blown at 90 miles per hour, and it was knocking out windows like crazy. So there's a lot of things about hail and what hail can do and what kind of damage it can do based on angle, speed, density of the hail. So there's a lot of things about hail that we don't fully understand completely. And so that's one of the things that we'd like to do. We'd like to get people to take pictures of the hail using a particular software, and it's on our website. It's called Polycam. And what that does is, what we'd like to do is take the pictures of the hail and turn them into 3D models to show the industry, especially the insurance industry and other industries, that hail is not always spherical. It's not always symmetrical, and it's not always spherical. You can look at some of the pictures of hail that occurred down in Argentina a few years ago. It's got spikes all over it. And so what happens to that kind of hail when it hits a roof? What kind of damages, how is that different from a spherical hailstone? So there's a lot of things that we'd like to do as far as research. So we do analysis, but we also are kind of moving more into a research role as well, because there's such a need in this industry, in the forensic meteorology industry, to understand it more. So I hope that answers the question.
Yeah, and talk about for a minute, Sam, because we always hear after hurricanes that the insurance becomes quite contentious about whether it's whether it's wind or whether it was flood that caused certain damage.
Exactly.
And that seems to be a constant battle.
Yes, and in fact, we all know that most of the damage, especially along the coastline, is caused by the storm surge. Well, some people may have insurance coverage for flooding, but a lot of insurance companies, they want to distinguish between storm surge damage, river flooding, and rainfall flooding. So you get it, you kind of start, seeing how many angels can fit on the edge of a pin. You can really start, diving down into these particulars. But when it starts affecting people's homes and their values and replacement costs and things like that, it's very important. In fact, one statistic that I came across, I think it was at a conference that I went to, where it was a disaster conference down in Miami, Florida, where they talked about most people, when, let's say they lose their home in a hurricane, the insurance company comes out there and let's say they insured their home for $100,000. Let's just say that's what they thought they were covered for. Insurance company comes out there and says, well, we're going to write you a check for $60,000. Most people, and I couldn't believe the statistic, it was like 3/4 to 80% of the people will take the money, because they just want their lives back. They just want to get back to normal as quickly as possible. They don't want to live in a motel for month and month after month after month. So they will take the lesser amount instead of disputing with the insurance company for the full value of what they were insured for. Now, if you're insured for $100,000 now, 5 years from now, because of plywood costs are going crazy, replacement cost is going to be a lot more than what you may have thought you were originally insured for. And so then you get into that problem. And so what happens is a lot of people end up having to get attorneys to sue the insurance companies to get what they deem or what they feel they're entitled to. But unfortunately, also, the legal industry also knows that a lot of people, they don't want to sue. They just want to get back to their normal life as quickly as possible. And of course, we all know that lawsuits, the wheels of justice, turn ever so slowly. And so it could be months or even years before a case is settled. And so we find that a lot of times the cases that we deal with in a legal sense are corporate clients, or when you're dealing with large industrial commercial sized buildings. But generally, individual homes, we don't really deal a lot with legal cases in that scenario, but it does happen on occasion.
Yeah, I think William Haggard's book, that he did.
Yes, I've got that book
years ago. Weather in the Courtroom is just a fascinating book, and I don't know if most of the listeners or most of the panels had a chance to read that, but if you haven't, go back and get it. I've got 2 copies in my library because it's just a spectacular book. It's
a great book.
And I'm always fascinated by the aircraft crashes. They seem to become, a big issue for the meteorologists because, you instantly want to know whether it was weather related. James, had an experience with one of the biggest ones that Haggard talks about in his book, and that's the L-1011 crash at Dallas, the Delta jet, James. And you talked about it a lot recently. Because did the Weather Service give the right information? Did the Flight Service, the FAA, give the right information? How much of it was the pilot's fault? And all these things, and then the jury or the judge has to decide how to distribute that liability. And so, it's like, wow, this is some crazy stuff here, and it probably gets pretty expensive to really investigate all that, I would imagine.
It does. And that's what steers a lot of people away from, unfortunately, hiring forensic meteorologists because they feel like the cost is so much. We, on the other hand, we look at the data and we feel like we put out an excellent product at an affordable price because we love what we do. I mean, I love doing forensic meteorology. I was in broadcast meteorology for a long time. In fact, I'm kind of going back into it, but I'm actually broadcasting now from KOAM in Pittsburgh, Kansas. So it's always been there for me, but I've also been very fascinated with climatology and weather events and weather research. And so forensic meteorology is just one of those fields that allows me to do all of those things. And I just absolutely love it. But I was thinking about James, we had that tornado that went through his property a few years ago, what his experience was with the insurance company. And, the good thing is with big events, generally insurance companies, they know that a tornado happened. They're prepared to pay out to people. But what we've found is a lot of these cases, when they're like borderline cases or when they're like isolated cases, that's when we start to find a lot more litigation.
James, any comments on your experience since you found yourself at the center of a disaster a couple springs ago?
It was all good. I mean, this was a pretty well publicized event, and it affected a very densely populated area, and the adjusters were in there. We had to check very quickly, and I have no complaints. My biggest problem, most of the damage was, the timber damage. The insurance that's not covered, and you got to clean that mess up on your own. But that it is what it is. I mean, again, I have zero complaints about the insurance process. It worked very well for us.
And I think it does vary from company to company, and not all insurance companies are bad. And I'm not trying to knock the insurance industry, because if you look at it, one of the reasons why forensic meteorology has kind of taken off as well is because the insurance company was subject to a lot of fraud. A lot of people were simply wanting their roof replaced, so they were making claims for hail when there in fact wasn't any hail. They just wanted a new roof. So the insurance companies were also on the other side, or the flip side of the coin, in that there was a lot of fraud. So it can kind of go both ways.
Yeah, Sam, I had a question.
Go ahead, Jim.
Yeah, harkening back to the hail that you talked about, and I could certainly resonate with your frustrations that hail seemed to take a second stance, and it's like, well, it solves and all that. But have you ever seen some of the stuff that the insurance business too for home safety have done with hail?
Unfortunately, a lot of the data that they collect or the research that they have done is what they consider proprietary. And so they don't really release that information. I have a feeling that there's a lot of data out there like, especially, and Anna can probably speak to this about GIS, because she's kind of our GIS go-to person, where, there's probably been a lot of cases or claims made on a particular storm to an insurance company, and they gather that data, but we don't have access to that data. I would love to get my hands on that data, because one of the things, and there was a paper written on this a few years ago, where they made a comparison between what was reported to storm data versus what they were doing out in the field. They actually had a hail intercept team that was specifically following a hail core around, collecting the hailstones, the size, the weight, the density, and all this. And when you looked at a map compared to what was reported to the Weather Service versus what they discovered in the field, it was mind-blowing. Some of the biggest hail wasn't even reported. Even though they recorded it, it didn't get reported to the Weather Service and therefore didn't go into storm data. And so, unfortunately, a lot of our industry relies on that storm data database that's incomplete. And I wish that there was a way around that, but unfortunately there's not, because the Weather Service employees, they're very limited in their time and their resources. They don't have time to sit there and take in every single hail report that comes in. They just want to verify the warning. Am I wrong in that, or am I off base? I don't know. Someone from the Weather Service could probably comment on that.
Well, I can add a couple things, because they may not have added everything in there, because there's a certain limitation in storm data. When the publication comes out, they actually filter out a lot of the reports when they're too close to space and time to each other. And so I could understand that, but and I've read some of the publications. This is from severe storms conferences to annual meetings, and I think it's Ian Cmyk is the lead principal investigator in the hail project. I think we were talking about. I know he was reporting on some of those things, but I didn't know if there was anything that they're instructed to say, no, this is proprietary. I do know they rate shingles and publish that, like the best shingles and worse in withstanding hail. So there are things like that, but yeah, there might be instances where some of their reports haven't gotten in. I mean, it just might be that, and I don't know if it's anything that's systematic or intentional on the Weather Service's part. Right. It just, the information just didn't get to them, and so forth. But yeah, it'd be worth. I could always ask Ian, hey, what is your policy, right? Are there any limitations?
And I think also a large part of it is a lack of education or a lack of knowledge. For example, it would be great if forensic engineers, forensic meteorologists, and insurance companies all got together in one room and talked about these things. What is it that you exactly need? What do you need as an insurance company to help your customers and your clients get the claims paid that they need claimed? Forensic meteorologists, this is what we're needing from the database. The forensic engineers, same thing. This is kind of what we're looking for. So I think there's just been this disconnect, unfortunately, between those disciplines. And so I'm hoping that we're going to start working more closely together to kind of bridge the gap, so to speak, on that. I know forensic engineers were brought in on the enhanced Fujita scale. And so I would like to see more and more of that, certainly.
Sam, talk about some of the more high-profile cases that maybe you weren't involved with. I know you probably can't speak to, but some of the ones that you found interesting over time.
Well, we seemingly get called into Fort Smith, Arkansas a lot.
Oh, Lord.
Of course, we're based in Tulsa, but Fort Smith seems to have a wind. They have a lot of wind events, and a large part of that is because the supercells just blow up in central Oklahoma. Then by the time they get to eastern Oklahoma and western Arkansas, they formed into a squall line or a bow echo. And so then you get these downburst winds and these microbursts that occur along the leading edge of these squall lines, or even QLCS type tornadoes, which is another area of fascination for me. And so they hit the Fort Smith area. And so we get a lot of calls about that. We just did an apartment complex in Fort Smith where the roofs were all damaged. And so they were having to sue the insurance company because the insurance company was wanting to say it was from previous damage. And so then we have to go back. And that's the other thing is in state to state, the statute of limitations changes or is different. In Arkansas, it's 5 years. In other states, it's 3 years. In others, it's 2. And so we kind of have to take that into consideration as well. And so we'll go back a period of time, back to the statute of limitation. We'll look at all of the events that occurred during that period of time to try to see if we can ascertain as to which event caused the damage. And then we'll coordinate and we'll work with the forensic engineers to do the same. And so we'll kind of collaborate together on some cases like that. But I wouldn't say I've been involved in a real high profile case as of yet. But I'm sure that's coming down the road.
Have you ever had to sit in on a criminal case? Because that's not unheard of that a meteorologist might be.
I have not, but I have read about them. As a matter of fact, one of them, I'm putting together a continuing education course to present to attorneys so that they kind of understand what forensic meteorologists do and how it can help their profession. And one of the slides in the presentation is about a case in Troy, New York, back in 2002, where a guy was accused of murdering his 2 friends. He supposedly found their bodies in the apartment. Well, his alibi was that he was snowboarding with his son in a mountain range not too far away. Well, the prosecution hired a forensic meteorologist who came in and said there was no snow. In fact, it was raining, showed the radar images of the rain, showed all the data indicating that it was raining and not snowing. Needless to say, the guy is spending time in prison right now. Probably, or perhaps a large part, due to the forensic meteorologist testifying about the fact that it was raining and not snowing, and that totally blew his alibi.
So we're binge watching Better Call Saul right now on Netflix, and right. I'm just wondering if somewhere there in season 4, maybe a forensic meteorologist will pop into the.
And here recently, the Florida Supreme Court. I don't know if you've been following this, but there is a lot of issues going on with the insurance industry in the state of Florida, and the Florida State Supreme Court has recently ruled. And I believe, and I may not be correct, but one of the higher courts here recently has ruled that engineers are not qualified to testify about meteorological data. So what that means is that there's going to be more and more of a demand of meteorologists to testify in particular cases because, according to the courts, they are the ones that are expert witnesses and are the only ones really qualified to speak to and about weather data. Now that's good for my industry because it means that there's going to be an expanding market and there's going to be a lot more opportunities for us to do our job. But that's kind of the direction that forensic meteorology is heading. Is it's, a long time ago when there was doctors, there was just plain old doctors, right? Then they became specialists, cardiologists, podiatrists, pulmonariology, all of those, oncologists. Well, meteorology may be kind of moving in that direction where you have forensic meteorologists, you have severe weather specialists, you have, maybe optic meteorologists. I don't know, but it's kind of becoming more and more specialized.
Yeah, it really could be. So Anna, what appealed to you about the forensic side of it? What made you make the jump? And what has it been like since you got in there? How would you advise young meteorologists that might be coming along that might say, hey, that could interest me?
Yeah, so I've always been interested in forensic meteorology. The first time I heard about it in my undergrad, I thought it was the coolest thing in the whole world. I was like, okay, I want that job, but I have no idea how to get it. Okay, no idea at all. So one day I just saw a posting on LinkedIn that Atlas was hiring, and I reached out to Sam, and he called me that night. We ended up speaking for like 2 hours, just about anything and everything. Turns out he used to live about 15 minutes from where I live right now, which is crazy because no one has ever heard of Valley, Alabama or Pine Mountain, Georgia. Yeah. And that's where he lived in Valley. I live in Pine Mountain now. So he was like, well, that kind of turned into a job interview. Let's meet the rest of the crew. And then they ended up bringing me on part-time. a big part of why they brought me on was because of my GIS capabilities.
Yes.
I took GIS in undergrad and grad school. I've done a lot with it, and it's a really great tool for meteorologists. Honestly, I feel like we're going to see it being used a lot more next year or two, especially. I know National Weather Service in Birmingham has done a lot with their GIS program as well, and it's been helpful for my research for sure that I've been doing in grad school. But for me, I got really lucky when I landed my job. I've always wanted to help people. That's why I got into broadcast meteorology. The first tornado warning I ever did wall to wall was going over my house. Thankfully, it didn't verify. But everyone was like, man, she's so good. She knows that area so well. I'm like, that was all my neighbors' houses. That's why I know it so well. That's my secret. But I was worried about not being able to help people as much leaving broadcast, but I'm still helping. I still get to scratch that itch pretty much because we're helping people deal with the aftermath of the storms, just not going wall to wall with that broadcasting anymore. So still getting to help people, which is what I'm most passionate about, honestly.
So what does it take to make a good forensic meteorologist? What are some characteristics, personalities, the person that might choose that as a career?
I really love investigating stuff. I've always been that way. I thought when I was like 6 years old, I wanted to be a forensic scientist. Did not happen. So when I got into college, I realized how much I loved meteorology. That's why when I heard of forensic meteorology, I was like, man, that's crazy. Like that's everything I've always wanted to do in one job. And so for me, I know when I'm working on a case and I'm digging really deep into weather data, trying to figure out what day a storm impacted a certain area, I'll look down and I'll think I've been working for like 30 minutes and 3 hours have passed just because the time flies. I mean, it's so much fun, and you really have to have that passion for combing through so much data and then running it all through GR2, putting it into GIS to try to compile it all in a way that you can look at it a little bit better. And for me, that's just been a blast because I love going through data. I love doing post-storm analysis. That's what most of my grad school research was on. So just keeping doing it.
Oh, I've got a quick question here. So I've worked in the consulting business on and off for many years, and I'm curious, like when you get a client, they obviously they come to you because they have an issue and they clearly have a position on that issue. How do you sort of draw the lines of this is where the objective science falls, and it may or may not align with where you want it to fall? It's on one hand, it's kind of nice being a consultant because you can bill them no matter what happens. On the other hand, you may come back with an answer they might not like. How do you deal with that?
Do you want to take that, Anna, or shall I?
Honestly, we both can. We're very vocal about that line, and we're lucky in that we work with that engineering company, and they're the same way, very vocal with that line. We're not going to compromise our scientific integrity. I mean, at the end of the day, we're all scientists. This is what we care about. It's what we're passionate about. That's why we do this. It's not really for the money. It's for the science. All of us can probably attest to that fact. So just for us, it's pretty cut and dry. If the storm's not there, it didn't cause damage. It's not there, and it didn't cause any damage. So Sam, you want to take some on that too?
Yeah, I was going to say, we make it very clear from the get-go, the data is the data. I'm not going to give you the result that you want. I'm going to give you what the data says, or at least to the best of my ability and interpretation. One of the things that helps us with that is the clients primarily contact the engineering firm first, because we're still trying to develop and grow the forensic side. And as I said, the engineering firm is our primary client right now. So one of the ways that they help with that is when they're contacted by a client, he doesn't necessarily tell us what the answer is or what they're looking for. He just tells us, here's the date, here's the address, tell me what happened. And then that leaves us free to do the science and not try to formulate an opinion that would necessarily help or hurt our client. And so that kind of shields us a little bit from having to deal with those issues. But that is a concern that in the future, as clients reach out to us, we're going to have to make it very clear the data is the data. We're not going to change the data to fit what you're looking for necessarily, whether it be positive or negative on your side. And that's why we try to emphasize to people to contact us first. A matter of fact, a lot of attorneys, we have one attorney that we work with very closely. Before he does anything else, before he tells the customer or the client that he's going to take their case, he's on the phone and he's calling us. Hey, I've got a client. This is the date. Here's the address. Tell me what you think. And a lot of times we're able to steer the attorney away from cases that would normally be a case that he would not want to take on because he's going to lose. Or because I think it, and to be honest, I'm not an attorney, so thank God. But I think some attorneys, they will take cases regardless, because they're just going to represent the law, as because everyone has the right to an attorney. So I'm not sure what their ethics are in regards to that, but I know that our ethics, we have a very clear line.
I want to ask a quick follow-up question, building on that. So, I mean, you've made this clear that in your company, this is your line, but there are a lot of forensic meteorologists in this space. I'm curious, is that the philosophy that they all carry? Or are there forensic meteorologists who are hired specifically by clients who work to try to examine evidence in such a way that it could help the case of the particular client?
I would hope that all forensic meteorologists have the same attitude as us, and that is, we're in it for the science. We stick to the science. We stick to the data. We stay in our lane. We're not going to comment on something that we're not familiar with or an expert in. I can't speak to other firms because I really don't know. I would hope that that's not the case, but sure, I'm sure that there are probably some that would, and without going into detail, there was one particular case that a forensic meteorology firm was hired to counter our report. And this particular forensic meteorologist veered away from the science and started getting personal and started questioning my ethics and started questioning my expertise and started questioning my qualifications, which had nothing to do with the case itself. And unfortunately for this particular person, I actually found huge glaring errors in his report. He had a map of a totally different town than the town that was being impacted by the storm. So I just simply responded back. I'm speaking about the facts of the case. And I pointed out, if you look at his page 17, figure 12, it's a map of central Illinois when the case is in Myrtle Beach, South Carolina. So, and that's why I think it's important to stay away from that, because you could find yourself in a deep hole. And when you're in a hole, stop digging, Yeah,
I can absolutely appreciate your view on that. And, where you're hoping to come from on this. I think where I'm left wondering a little bit about it, though, is we talk about in weather forecasting, for example, that all the time we talk about the fact that there can be honest differences of opinion, everyone
Yes.
trained equally on the science, but there is an element of uncertainty.
That is correct.
The forecasting of what's going to go on in the future. And I'm sure that applies to there's an element of uncertainty to what happened in the past.
Absolutely.
And so,
and in fact,
with that in mind, it could be the case that you have honest differences of opinion that could come about because as a scientist, you simply come to a different opinion. I mean,
that's
this
correct.
is something that you could look at the same evidence and see something a little bit different. So I'm wondering, even if in line with that, I'm really struck by your, maybe this is just me being more cynical than you are. I find it very difficult to imagine that science can be completely divorced from motivation. And the things that you're looking for. I love the process you're describing that you're going through, where you don't necessarily know about the case, but it also can leave this situation where, and I'd love your comment on this, maybe you're not attending to some of the particular details where some of the nuggets about the case that are important lie in that, because you're not being told to focus on anything in particular. I mean, does that happen too? Like, I just feel like this whole field, the more that you're talking about it, the more I'm wondering how all of these different processes work. Yeah.
Yeah. And in fact, if you looked at one of our reports, a large part of one of our reports are disclaimers where we talk about, just because we're, offering an opinion or an analysis does not mean that it's set in stone and it's the gospel, So we kind of cover ourselves a little bit with some disclaimers. And we also talk about, that there can be differences of opinions. We also cite. We also have like a bibliography at the end of our report citing all of these scientific papers that we reference and that we pull our data from. We also have a file folder where we get all of our source data. I mean, it's kind of like, in a way, we write a research paper on every particular event that we cover. And like you said, two meteorologists can look at the same radar screen and come to two totally different conclusions. And so we understand that. And we're not saying we're 100% right all the time, but we're doing the best that we can. And part of the problem too is the data quality. And this goes back to what we were talking about before of, if I'm pulling up hail data from the NCDC, let's say a hailstorm goes through an area at 2 a.m. in the morning. I don't know about you, but 90% of the population is asleep at 2 a.m. in the morning. They're not going to be up. They're not going to be outside reporting quarter-sized inch hail, So there's a lack, or there are holes in the databases that we as forensic meteorologists use. And I wish that there was, more data is to me is better. The more, I'm always looking for more and more data. And I also wish that there was like a one-stop shop where I could go like to one particular website and get everything I need. But unfortunately, there's not. Now, one of the sites that we use a lot is the Iowa State, the Iowa Environmental, an incredible resource for archived weather data. And Amazon is basically taking over the radar archiving. I don't know if a lot of your listeners or if y'all are aware of that. That is an excellent resource. So there's all these different resources that we use. And of course, we cite all of those in our reports that we write to let the other side know this is where we got our information from. Oh.
Are you saying, Sam and Anna, both of you, that the NCEI site is not an easy one to work our way through, and watching people laugh all the way along? I talked to some people today that was looking for a little weather data in eastern parts of Tennessee, and he simply said we could not find the information on the NCEI website. It is one of the most convoluted websites and most difficult to pick your way through.
It's all really slow too. Like some days I feel like it takes me forever just to get one page to load. I'm like, I'm just trying to get the stuff done.
Yep.
Yeah.
And I think
I've been on that site. I wanted to stick needles in my eyes coming out of that thing. It's brutal. It is just brutal. We have to take a break here, guy. I hate to do this. We could carry this on for a long time, but we got to take a break for Tony Rice. We'll come back and we're going to do picks of the week, everybody. So again, Sam, Anna, and Jim will need a pick of the week from you guys, and we're going to do that right after we hear from Tony. Again, Jen is off this week. We had a lot of really good emails this week. We're going to read those next week, but let's pause for Tony Rice. We'll come back with the picks of the week and more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
So
since its launch last Christmas morning, engineers have been hard at work deploying the James Webb Space Telescope, aligning its mirrors and cooling the instruments down to more than 400 degrees below zero. This week, we get to see the first images. NASA Astrophysics Division Chief Scientist Eric Smith has described it as seeing the universe turn its lights on for the first time. Even last week's test image from the telescope's fine guidance sensor, which is used for pointing the telescope and not really optimized for capturing faint objects, did just that, providing the deepest image of the infrared sky ever. That was topped today as we got our first peek when President Biden shared the deepest image ever taken of the universe, some 5 billion light years away. This showed off how scientists can use gravitational lensing to see what hasn't been seen before. Think of it like this: a tennis ball rolling across a trampoline. Now park a car in the middle of that trampoline and roll that same tennis ball. Roll it fast enough and it will roll around the mass as it pulls the trampoline down. That's what gravitational lensing does. It bends the path of light, which normally travels in a straight line, revealing objects behind. Another 4 will be revealed Tuesday morning beginning at 10:30 Eastern on NASA TV. The pictures promise to wow as well, and the targets further demonstrate the telescope's capabilities, particularly in the infrared spectrum. The targets include the Reno Nebula, one of the brightest and largest nebulae in the sky. It's located about 7,600 light years away in the constellation Carina, better known to observers in the southern hemisphere. Webb's infrared sensors provide the ability to peer through that dust and gas and see what lies behind, very, very far behind. Next comes the Southern Ring Nebula, nearly a light year across and 2,000 light years away. It's in the constellation Vela. This is a planetary nebula named for its roundish shape. It's also made up of gases, this time of a dying star. Again, it will be fascinating to see what lies behind it. Also featured is spectral data instead of images from WASP-96b. This is an exoplanet, and this data should provide insight into its cloudless, sodium-filled atmosphere more than 1,100 light years away. But my favorite is Stephan's Quintet, a compact galaxy group located about 290 million light years away in the constellation Pegasus. It might look a little bit familiar. The angelic figures at the beginning of the 1946 film It's a Wonderful Life, that's Stephan's Quintet. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
All right, let's do picks of the week, ladies and gentlemen. We're going to go around the table. Everybody share something related to weather that's cool. And mine, it's this heat risk product. I saw a tweet from the Weather Service in Boulder a few days ago. And Jim or Kim, how long has this been a thing? I've never heard of this. Don't all speak at once.
Yeah, I was going to say, go ahead. You put on your mic, so I was like, oh, Jim knows. I mean, I think what we, in some of the back and forth, maybe Rick Smith in our email chain had mentioned that this is a Western region experimental product of some kind. I hadn't heard about it before this appeared. So I thought that it was really neat.
It's interesting. They're categories: no risk, low risk, moderate risk, high risk, and very high risk. I guess they kind of go in parallel with the convective outlooks and these other things. So, but I've not seen that before. So anyway, that is my pick of the week, and you can dive in there and take a look at it. All right. So Kim, while you got you on the line, what's your pick of the week? Go.
Sure. My pick of the week is a Twitter thread, one that was filled with all kinds of the great meteorological conspiracy theories that motivated us bringing Jim on and having the discussion for the first hour of our show today. So if you would also like to see what we were looking at and commenting on, then you can check that out.
Awesome. And it's a great thread. That's awesome. And again, all of these will be up on the website, weatherbrains.com. Troy, what you got for us this week? Go.
Well, as former state coordinator for Cocoros in Texas, you'll recall beginning of June, I was out with Landon and Brandon, the outlets out at the WFO in Guam, live on the show. Happy to report that effective September 1, Cocoros expands into Guam. That's something that will happen effective September 9th, and I'm hoping they can grow the network out there. Colorado State, the amazing work they've done in the growth of Cocoros and putting everything together. Glad to see it coming to Guam.
Outstanding. All right, Neil, what you got for us this week?
So my pick of the week is a webpage by Andrew Young at San Diego State University on the green flash. So I went down the rabbit hole of looking at refraction versus absorption and ended up at a webpage that explains the physics of the green flash. And believe it or not, there is something more rare than the green flash called the blue flash. Ooh. And I suspect there's probably something called the violet flash that no one's ever seen, but he's got some awesome pictures and really does a great job of explaining the physics.
Wow. Outstanding. All right. We've learned a lot on this show tonight. This has been great. All right, Jim, go. Give us a good pick of the week.
Oh boy, I had this in mind because last time I think I was caught on unprepared or something like that, and so I have a couple, if you don't mind. One of them is, I mentioned this before, you can pick your name, a color name, and they just need a few million more and they're all done. So that's colornames.org. And I mean, I think there's some funny ones, but I haven't seen where they're sharing the actual names. Although if you want, you have to go through 1.7 million of them. And I think anybody's just doesn't have the endurance to do that. But having said that, I laid that one out there. And then there's another one I shared, which is, there's a new book out. It's an open source book. Anybody can download this. And it's literally, it's kind of like it's not an encyclopedia. It is the reference book on warnings. And I mean warnings of all types, if you think about it, from literally the climate scale all the way down to local neighborhood scale, and the attempts to try to fill in this valley of death between areas of research and different disciplines and so forth that come to bear on the whole warning concept from end to end. And so I think Kim could probably add a little bit more to this, but it's a lot of authors. It's a whole bunch of authors involved in this, and it's hosted. It's actually hosted by the British Met Service and the World Meteorological Organization.
Very cool. All right, Kim, any notes from you on that book?
Nothing in particular, except to say the social science representative on there, Brian Golding from UK Met, is just amazing. And so this reference, it was something that he was really spearheading, pushing the organization of this volume. And the WMO has been working on this project for a long time. So absolutely should be considered what Jim just said. This should be considered at this point sort of our gospel best knowledge and the frames that we're using to try to understand how we can improve the warning system.
Absolutely fantastic. Okay, Anna, let's turn to you. Come up with something good. Go.
Mine was going to be the green sky, because immediately, who sent it to me first was my mother. And it's always her, because anytime she sees a cool weather picture, Facebook messenger immediately.
Thanks, Mom.
Straight to my page. So that's what I got all week, was from different family members, various members of our extended family. Green skies asking me why it happened, and if it was real. What's the big one?
And the mystery has been unlocked by this show tonight.
Yeah,
so there you go. All right.
Tell them all to watch this instead.
There you go. All right, Sam, go. What's your pick of the week? Give us something good.
Well, this is in a nod to Neil, and I think he will appreciate this. This is a picture from Australia, and it's the flooding. So while we're dealing with the drought and the dryness here in the United States, they're dealing with the flooding. And this was the headline in the, I think it was Sky News in Australia. Australia floods, unfounded cloud seeding claims spread online. So I thought that was kind of
that's in the top 10 list.
Oh yeah, I do agree. It would be great fun to do a conspiracy theory show. I mean, we would have a ball with that. It's going to be good. All right, Bill Murray, pick and guest, and what you got going on here?
Yeah, well, after we do that conspiracy show, we may not be able to show our face on the internet again after that.
That's true. Yeah.
My pick is William Haggard's book, Weather in the Courtroom. I forgot just what a joy. Well, I say it's a joy. I mean, it's full of tragedies. But in terms of the learning that's there, and Neil, I'm kind of shocked that the government gets sued as much as it does. I didn't think that was even a thing.
Oh, it's a thing. I got sued on average about 4 times a week. It usually dealt with fisheries regulations.
Well, I was kind of appalled because, like on the Delta 191 case, James, the supposition was that the Weather Service didn't act fast enough to produce a severe thunderstorm warning or or whatever, as that storm developed so quickly. But the judge cleared that out and said that was not the
Well,
case.
it's a no-lose situation because they sue the government, and if the government doesn't respond fast enough, then they can fine you. So worst case is you make money. I mean, it's really annoying, trust me.
Yeah, sounds like a cottage industry there, unfortunately. But in that case, on 2001, the court found that the plaintiffs had failed to prove the United States of America was guilty of any negligence in that. But the number of cases and trials that came out of that, James, was just absolutely flabbergasting.
I think it's also one of the reasons why they instituted the FAA terminal Doppler radar systems, in addition to the regular WSR 88Ds, was because of that Delta crash there in Dallas.
Yeah, and because of that, we came pretty quickly to the end of those type crashes in the United States. We only had a couple more after that. So that's really good news. But that's my pick of the week, James. I'm not going to take the foghorn, so you get to take your finger off the button. And we just got confirmation that Adam Houston will join us next week. That's going to be a fun show. Tim Heller's going to join us on the 25th. And then we'll have a special show on Thursday the 28th. Allie Hirschlag will join us talking about roadways. We will not have a show on August 1st. And that's all the guests that are coming up on WeatherBrains, James.
Awesome. So let's see here. Anna, you want to promote your social media feeds or anything? This is your big promotion moment. Go.
I did leave all of my social media pages up when I left broadcast. So I had probably way too much fun when I announced that I was leaving my job, and people started guessing what I was going to do. And it was so much fun. 300 comments later and still nobody got it right. So if you want to go get in on that fun, go through the comments. It's a blast out there. Meteorologist Anna Sims is my social media for all of my pages. If you just look that up, you can find them. So.
Awesome. And thanks for your time tonight. It's great having you on the show. Sam, plug away. Tell us some websites.
I just want to talk about atlas-weather.com. That's our homepage if you're interested in more about Atlas forensic meteorology or forensic meteorology in general. And I highly recommend any meteorology aspirants out there that are looking to get into this field. I highly recommend that you look into GIS as a minor because I think that's the direction that is going. GIS is a huge part of what we do, and it's only getting bigger.
Yep. Okay, well, great. I hate to tie this thing up here, but we've got to move on here because we're at the time. So thanks to everybody for being on the show tonight. It's been a fun show.
Thank you.
We're typically here every Monday night at 8 o'clock Eastern, 7 o'clock Central. A lot of people watch at live.bigbrainsmedia.com. And remember, we're on a new YouTube channel, on WeatherBrains on YouTube channel. But most of you listen. We know that, and we thank you if you watch, listen, whatever. If you want to get in touch with us, we have some great emails this week. We're going to do a double email segment next week, but the email address is email@weatherbrains.com. All of the picks of the week and show notes will be up on the website, weatherbrains.com. So on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week, and God bless.
Yeah,
thanks everybody.
Troy,
show.
Quick question, Troy, for my pilot connection here, Dr. Neal, maybe anybody else. Pilots used to call flight service for, specific weather briefings. What do they do now?
I'm hoping they still talk to the flight service, even though it's a contract. I think that a lot of that's contracted out now.
A lot of the
consolidated.
Yeah, a lot of the commercial flights have their own in-house weather meteorologist, and there's a big disconnect sometimes between them and what the weather service is issuing, which is the FAA is trying to reconcile that through some recent RFPs. So we'll see if they get it right this time. It used to be the next gen 4D weather data cube, but we'll see what happens.
Yeah.
Always a great answer.
I know Delta is actually looking for meteorologists right now. So a lot of the airlines have their own meteorology departments.
That's